Hey, everybody. Everybody can hear me okay? Excellent. Awesome. Nice to meet you. I'm here today to talk about deploying Teleport at scale with custom infrastructure. My name is Jussi. I work at Dropbox. I'm an infrastructure security engineer there. I'm the lead engineer for the Teleport implementation at Dropbox. Haven't been at Dropbox too long. Started there in March of this year. Before that, I spent about 4.5 years at Appian, working on security ops tools. So stuff like building a custom SOAR platform and a serverless log stack in AWS and various other security projects. My free time, like hanging out with my wife and my dog, like traveling, like eating good food, like driving cars and road tripping, so combining a little bit of travel and cars. I've also recently been bitten by the pickleball bug. I'm pretty bad at it though, so it's a story of gradual improvement there. I'm super excited to be here today, speaking to you about our little journey with Teleport. So the agenda here, pretty much at a high level, I'm going to give you an overview of what Dropbox's infrastructure looks like, to explain the custom infrastructure piece of the presentation title, talk a little bit about the use cases for Teleport that we had, as well as the final architecture that we ended up with, and then spend the rest of the time talking about solving for some of the challenges that we encountered with all that custom infrastructure, with all the custom stuff that we've built over the years to operate Dropbox, the product. Hopefully we'll have a little bit of time for Q&A at the end as well. So without further ado, Dropbox 75,000 feet. I'm sure most of you are familiar with what Dropbox does, but we host files for like 700 million people worldwide, and do a little bit of other productivity software stuff on the side as well. We are infrastructure-wise a hybrid cloud company. We run about 90% of our nodes in our own data centers. So those consist of our 4 major data centers here in the US, as well as global points of presence that we use to speed up using Dropbox.com and various other services for our users. And then 10% is AWS, AWS being distributed globally across several AWS regions. All told, we have over 30 metros. We call them metros. Ranging from tens of thousands of nodes in some of the metros to like 100 or less in others that are points of presence. All told, 70,000 nodes. So it's a pretty big environment, mainly Linux nodes with SSH as the protocol for access. On the corporate side, we have a little bit of RDP that we're also trying to roll into Teleport over time, but mainly SSH and Linux. Based systems. We have a little over 1,000 users who have some sort of production access out of our 2,800 employees. And what's fun for me as the lead engineer for Teleport, as well as the team that I've been working with on this, is that our production environment, our acquisition subsidiaries, and our corporate environments all have unique infrastructure configurations, so none of this stuff really works one for one. With that said, we have a lot of funky stuff as part of that custom infrastructure. Number one, we have a custom IAM application that assigns groups access to SSH infrastructure based on labels assigned to nodes. I don't know if that sounds familiar to anybody, but we were a little bit ahead of the curve there. But obviously, we're trying to work on this with Teleport and get that access replicated into Teleport. Teleport itself, as well as everything else that we run at Dropbox, or almost everything else that we run at Dropbox, is deployed entirely by a custom CI/CD stack that was built in-house, custom built tooling, custom developer infrastructure, and a custom monitoring stack that has sprinklings of some open source software in there. And then obviously we have tons and tons of smaller customizations that we use for our tooling. So that's made the Teleport deployment journey pretty fun for us. And in terms of, I mentioned we have that IAM solution that already had our labels set up, and we have some modicum of RBAC within our environment, why did we decide to go for teleport? Like, what was the motivating factor there? So our use case, like I mentioned, is mostly replacing human SSH access at this stage in production, and then SSH and RDP in the corporate environment, and then landing and expanding from there to machine use cases, potentially application proxying, and other use cases for teleport over time. The motivation for this really is a couple things. Implementing phishing-resistant WebAuthn and MFA for our infrastructure, integrating Okta for our infrastructure access, so getting rid of some of the differentiation between all of our kind of web application type of tooling and then our actual core infrastructure. We wanted to improve the auditing capabilities that we have, and then unify the infrastructure access configuration across different environments, so that if I, as the security engineer, get a compliance requirement, or we just want to do this, we want to lock down our sessions real fast. Let's just be able to deploy that to every session all over Dropbox, rather than having us pushing it to production one way, corporate another way. Some subsidiary, might still be on without that configuration 6 months from now, et cetera. So we wanted to bring everything together in terms of that configuration. And then over time, as we're trending toward, we have a pretty big push to implement safer production tooling that doesn't necessarily require people to have raw SSH access to servers in the first place. We're looking at using teleport and the access request features to also just reduce the people who persistently have any kind of access to infrastructure, and making it just-in-time provisionable for people in emergency situations, maintenance, whatever they may need it for. And on top of the use cases and goals that we had, we also came up with a bunch of requirements, and a lot of these were really from the SREs that I interact with, who currently manage our SSH bastions and are responsible for the reliability of much of Dropbox. Number one, like I mentioned, we're pretty big on-prem, and we wanted to avoid introducing any kind of foundational dependency for infrastructure access on AWS. So that was a big thing for our SREs, that we needed that. We obviously needed to be performant at that 70,000 node scale. Like I mentioned earlier, we wanted a single point of entry for all Dropboxers to make it really easy for people to manage infrastructure, kind of like we've been talking about earlier in many of the presentations today. If accessing infrastructure sucks, then people don't want to do it the safe way. And then finally, we obviously needed an architecture resilient to single points of failure. We wouldn't want our node access to go down just because of some singular point of failure or some single thing going wrong in the stack. How did we address those requirements? Number one, for on-prem, using etcd backend for all the non-AWS clusters. Wasn't really any other options either, but we couldn't use Dynamo for that linkage reason. So we're using etcd. Luckily at Dropbox, we use etcd for other stuff as well. So we have a team that's pretty well versed in running it. Luckily, that makes my job easier as the teleport guy. I have some help with etcd if need be. We do have alerts for bad backups, so I'm happy to report that. Performance at 70K node scale, we addressed that by basically deploying a production cluster per major metro. So we have, like I mentioned, 4 major data centers here in the US. They all have their independent teleport clusters. Their etcd is in that metro, which is a good thing also, because then we get to use fairly low latency between all the components, and the performance better that way as well as just reducing the gargantuan scale of a single cluster potentially in production. Single point of entry. We joined the clusters from everywhere with trusted clusters, and that way are able to provide a fairly seamless experience for people. And I'm personally trying to find some nice TSH hacks to make it even easier for people to connect to any node that they want. So we have an example TSH config file and other things that make that a little bit easier. And then obviously leveraging high availability and failing over from the root cluster to the leaves, which are also accessible at Dropbox as a last resort, so that we have a pretty good amount of reliability built into the teleport deployment. Now that we kind of addressed some of the requirements that we had for the project, the rest of the talk, I'm going to delve into some of the skeletons in the closet about our custom infrastructure and how we worked around that. So number one, let me chat through the architecture here real fast before we go into that. So architecture-wise, like I mentioned, we spun up dedicated AWS infrastructure for our multi-region root cluster, as well as the corporate cluster and the centralized logging for both our audit logs in S3 as well as session recordings in S3. We have the production clusters that join using trusted clusters over to the dedicated AWS infrastructure, the root cluster. And then in corporate, we make heavy use of node tunneling for corporate infrastructure from various different network segments, from various different AWS accounts to all join to that AWS cluster. And that AWS corporate cluster, our networking team on the corporate side was nice enough to give us some network space, so that all works nicely. That all works nicely from that point of view. Happy path, obviously the users need to be able to access the infrastructure through the root cluster, and then fail over every cluster that we have. You can independently go use that as well. Makes authenticating into production a little bit more difficult because you need to know which cluster each node is actually connected to, but that works decently for failover. In terms of our users, the users, like I mentioned, we have some modicum of RBAC already set up in our environment. So how did we go about figuring out what users can actually access? It was a challenge. Spoiler alert. The Dropbox production authorization information lives in our custom IAM solution. It's basically, we have hundreds of different permissions that you can gain against Dropbox's production infrastructure, and that none of that data currently is synchronized to Okta. So, and in corporate, we had an even more interesting setup where we in fact had AD attributes that were LDAP queries that returned the people who had access and groups that had access to a particular host. And then, we obviously needed all of this data available to teleport, even though none of it was in a readily teleport consumable format. So we went off and started engineering around how we're going to solve for the problem. And number one, we worked with our corporate admins to tell them that they should migrate off of indeterminate LDAP-based access controls and start labeling their nodes with some sort of modicum of idea of what service is it running, what team is it owned by, and then synchronizing all of those permissions and labels into that custom IAM system. So that now we got to the first step was getting everything to the same state, regardless of whether it was production or corporate. Secondly, we wrote a custom interpreter that runs, it's a little Kubernetes task that reads data from that IAM solution. It translates it into teleport as roles, as well as the Okta SAML configuration using key control. And then that interpreter also automatically manages the roles. It updates only whatever needs to be updated, and then removes all sorts of stale roles. So if some label is no longer used for production access control, that role just gets thrown out when it's no longer needed, so that the roles don't indefinitely expand till the end of time. So what does that look like? So again, we have the custom IAM solution, which handily enough has the ability to just export all the data into JSON that's readily readable for us and interpretable for us. And because our machine database contains all the labeling for the nodes, it was actually relatively straightforward for us to build a tool that's capable of taking that entitlement data and translating into teleport roles. So what that task does is, yeah, it just it creates a bunch of YAML files. It issues a bunch of T-control creates, and it stores its state in the persistent data store, in a persistent state store where that where all the hashes for the existing roles are stored. And on the teleport side, we end up with a bunch of very simple roles. So in my case, for example, my user is going to have, owner equals infosec team, as well as service equals teleport and a bunch of other entitlements. And then we have a really big SAML connector. So we are currently running at about 450 roles, and all the users are mapped to the roles using the SAML connector. That is a little bit of an unwieldily large SAML connector. So we're looking forward to auth rules and being able to kind of rewrite some of that to be asynchronous rather than a humongous SAML connector. However, we've had no issues with it. It is working right now as it is intended. So that's how we went about solving for RBAC. Now, the other challenge that I sort of hinted at earlier, and maybe the Kubernetes logo here gives it away. We had to figure out how to deploy this custom code into our environment, as well as deploying the teleport auth servers, as well as our monitoring and audit log exporting and all sorts of other stuff. So the CI/CD system at Dropbox is simultaneously pretty cool and a little bit challenging. So our initial idea was, okay, let's go off. Let's try and use the teleport deb package to deploy teleport. Turns out that did not work for the nodes. It worked okay for the servers, didn't work for the nodes. Went to another infrastructure team. They said, why don't you go off and just deploy this using Chef and your standard kind of cookbook for deploying a host tool. Well, I am but human, and I screwed up. So once I screwed up, I went back to this team to tell them, hey, I screwed up and I need this rolled back. They said, well, we're going to roll back literally all config management changes for everything we run in the environment. At that point, I was sort of concerned because that obviously introduced the possibility where me or someone else building a bug into our teleport configuration that blocks teleport from being used may also necessitate the rollback of something else that was critically broken for another Chef managed service. It was kind of a mess of dependencies that we didn't want to deal with. So we went back to the drawing board with having already deployed some of the nodes and started brainstorming a better option. What we came up with was, as was earlier mentioned, luckily, teleport is a singular executable. So we started just using the tarball of teleport as it is into the build process. We just threw it in there as a dependency and basically just deploy that as a file with the package that we're building. Along with the teleport executable, we're also throwing in a bunch of support scripts and tooling that we're using for different use cases to support and augment teleport. And then we got rid of systemd, and instead we're using our custom service daemon runner that's going to keep teleport running. It notices if teleport's health check, the readyz endpoint is not returning a 200 on a particular node, automatically kills teleport, restarts teleport, and monitors it, puts out a bunch of metrics for us to monitor. So we actually, along with just making it so that if we make a mistake with teleport, we can roll it back independently and go fix it without impacting anybody else's services. We also got a bunch of stuff for free from our custom infrastructure and deployment tooling that we wouldn't have otherwise had if we tried to run it on the bare metal host as using Chef. What does that look like? So yeah, here's sort of a high-level overview of what we're doing. So obviously we take the tarball, we put it into the build dependency mirror. The build tooling that we have, it's based off of Bazel, but run in our environment. That goes to the dependency mirror. It grabs the teleport executable or the tarball, untars it to get the teleport executable, as well as the latest versions of all the scripts that we manage using our repo. Builds a package for us and then deploys that package. If it's a server, it provisions a host for us where it initializes the tooling. And if it's a node, it just pushes the teleport package onto all the nodes and then instantiates using that custom daemon runner, brings up teleport on that node, starts monitoring it for uptime, restarting it, bringing it down if the host gets decommissioned, etc. And here, I want to draw your attention kind of to two things here. Number one, the linkage between the script and the machine database and service discovery part. So the scripts that we wrote actually interact with our machine database to query the attributes for this particular host that teleport is deployed upon. It runs every minute. It checks against the machine database. So rather than using dynamic labeling in a traditional sense, it's actually using our custom machine database to keep the teleport labels up to date and rebooting teleport to apply the configuration whenever there's any changes to the host. So we still have the singular source of truth for machine labeling in prod without having to kind of manage several different potential dependencies. Same with etcd peers, using our service discovery, automatically keeping the teleport auth servers up to date with the latest etcd peers, etc. And then, over on the right-hand side there, with the teleport servers, we have a couple of other extra goodies that we threw in with the teleport tooling. One is audit log exporter, which translates which grabs the files off of the teleport servers and uses an open source tool called Vector to dump them into S3 so that we can put them into our SIM and have security or the incident response teams have access to teleport data. As well as the metrics exporter, which basically just scrapes Prometheus and converts our metrics into our custom monitoring system so that we can build our cool Grafana dashboards and know if something's going awry with teleport. So that's pretty much the story of how we deployed teleport. The custom infrastructure piece really is, you'll notice the teleport logo up there. Literally nothing else has a logo. Like none of this has a logo. It's all custom stuff for Dropbox. So it took a little bit of figuring out how to make it work. But I'm pretty happy with where we ended up. So obviously we solved a lot of technical challenges, built a fairly robust deployment model for teleport, and integrated all of our custom tools that we need to run teleport with our environment. We are up to 7 teleport clusters at this point. So we have a staging cluster, several places, as well as several production clusters, corporate, and the root. We are at thousands of nodes at this point, single thousands, and the goal is to pretty aggressively start scaling teleport, get to 100% of the fleet having the option to be accessed using teleport by the end of this quarter. And then, like I mentioned earlier, our goal really was our first of many goals with teleport is to deprecate non-emergency human access in 2023. We look like we're able to hit that. I'm just waiting for somebody to tell me that they have a weird use case that we didn't account for that's gonna prompt that timeline to be extended, but hopefully not. So that's pretty much it. Really wanna express my gratitude personally and on behalf of Dropbox, the whole teleport team. That's been super helpful for us, enabling our large-scale deployment as well as all of our custom stuff and listening to our feature requests, bringing bug fixes where needed. It's been a great experience deploying teleport. I look forward to bringing it to all of Dropbox, and hopefully we can have somebody else here maybe next year talking about TSH hacks or some other cool thing that they built using teleport that maybe wouldn't have otherwise been possible. So thank you very much, and hope everybody enjoys the conference.
Do we have any questions from the audience?
Hey, did you have the option of using the same teleport clusters for production and corporate? And if so, what were your thoughts around separating them?
I didn't really have the option to. Our corporate and production are essentially two entirely separate environments. It would have been maybe possible if we had had a fully publicly available teleport endpoint or teleport cloud or something like that. But we by consensus decision decided that we're gonna put this behind VPN for now, and then we're gonna start. We're gonna work with our overall zero trust ideas of potentially getting rid of the VPN as time goes on, and then maybe we can reevaluate it then. But otherwise, right now, the networking, which was already non-trivial, would have been a complete nightmare if we tried to bring everything together.
I have a question around your custom IAM tool.
Yep.
Are you still using that today, and does it actively add roles into Teleport?
Yeah, we are actively using that today. We're going to keep using it for the foreseeable future, probably, because it's not just production SSH. It's like literally everything at Dropbox is entitlements for everything at Dropbox are run through that. So it's a large project to migrate off of it. But yeah, so the way that it works is that Kubernetes task I was talking about earlier goes off, reads output from that tool, and then translates it into teleport roles. And yeah, we're running that sync every 10 minutes right now, and until I turn it off.
So I had two questions.
Yep.
So first one is, how long has this journey been for you?
I think we're about 6 months at this point. So I basically started working on this once I got to Dropbox and once I got kind of out of onboarding and had some modicum of idea what I was doing. And with all this custom stuff, I re-engineered it a couple times. So
Sure. And the second question is, how has the feedback been on the user experience of trusted clusters and logging into all of these disparate clusters?
Yeah, so right now the trusted cluster piece, we're still working on making that the default access pattern. So we actually right now are using the Leaf clusters directly for our production pilot. So the pilot users are actually using a TSH alias, which automatically decides the right proxy to use based on the host name. As far, we do have the staging version of the trusted clusters up, and I've been using it myself. It's been pretty decent as far as for me, just testing it out. But I think I can probably more robustly comment on that in a couple of months when we have the full trusted cluster experience for people.
Awesome, thank you.
Oh yeah, hi. I have two questions related to the identity. One is you mentioned that when you guys try to migrate all of the existing the attributes and access to teleport, right? Because kind of interested because earlier these attributes have been LDAP, right? So what's the reason that you're not moving it into the Okta rather than the teleport?
Yeah, so part of it is that our Okta environment is managed by a separate team. So we actually have, as far as managing the production SSH entitlements, those can be requested and applied by any team that owns a particular group. So if they need some SSH access, they can just go request it. They don't need to work with the IT team to work on Okta, etc. So we built this in order to facilitate not these teams that are used to managing SSH access that way, not having them have a completely new workflow, and also just to kind of make sure that we're not necessarily dependent on the Okta team's input for managing teleport entitlements, etc.
Got it. Thanks. The second question. So you mentioned that you have a SAML connector inside of Kubernetes, right? And yes, you might thinking of a rewrite it. Right? So do you mind tell exact what SAML connector you guys use, and if it makes sense, can you go into a little bit detail on some of the challenges you run into?
Yeah, sure. So the SAML connector, what the Kubernetes task does is it goes off, it builds a SAML connector based off of all the role entitlements that are found in our custom IAM system. Otherwise, beyond the, obviously it was a little fiddly getting it working in the first place, but that, I suppose, is any more than 10-line piece of code. But the biggest thing for us was once we started deploying the root cluster in AWS, we ran into some issues with DynamoDB, with DynamoDB's kind of item size limit for that SAML configuration. So that is something that we've been working toward, and again, a reason why we're looking forward to auth rules and making that a little bit more manageable. That's been the biggest concern. Otherwise, it's been working perfectly.